Thank you, Mr. President. It pains me to say that, but all joking aside, I'm teasing him. Dave has done a terrific job for 2 years leading the organization. This is always a pleasant panel to put together. We've been doing it a long time, at least as far back, under different names, but under the more current name, Asset Health Strategic Initiative, at least back to, I would say, 2010 when we were in Montreal on a joint event with CARS and RAC up there. So we've got really our stellar panel again. Instead of Nicole, we have a newbie, though. We let Bo Thompson on here, and so we'll introduce everyone, but we're really pleased to have everybody. And let me see if I can get to those. I think I won't. I got it back to start by introducing your panel, and then I'm going to get out of the way and let them do their thing. But to my immediate left is Bo Thompson, who is Director of Asset Health for AER. He's held management and leadership positions in the rail industry since 2005. Prior to that, he spent time repairing freight cars and troubleshooting locomotives. Currently is AER's Director of Asset Health, has plans to pursue an MBA and continue to learn new and exciting roles within the industry. The overall goal for his career is to have an impact on those he has the pleasure of working with. And Bo is always interested in learning new things. Next, we have David or Chip Summey, who is Director Asset Services for Rail Inc. Corp. And let me see if I can get back there. There's not anything else on here.
Oh, that's enough. That's good enough.
That is more than enough.
All right. Well, Chip is familiar to all of you. He does a lot of things at Rail Inc. and Director Asset Services says a lot. And then Jamie Williams from Norfolk Southern with additional responsibilities and a new title to go with it. So Jamie is now a director at Norfolk Southern. He began his railroad career with Norfolk Southern in 1990, initially as a locomotive laborer, and shortly thereafter accepting a position as a carman in 91. 2003, he transitioned into a supervisory role, which prompted many more advancement opportunities in field ops. In 2007, he landed in Atlanta as the superintendent of air brakes before being promoted to manager of car administration in 2012. In June of this year, as I alluded to, he was elevated to director of car administration with responsibilities now including DNS program repair shops, in addition to wayside detection and his AR and FRA compliance, car repair billing, and several tech committees, including arbitration and rules. And if I recall, I think Jamie was actually a former chair of Brake Systems Committee, or certainly was on there a while, and he is the current chair of the Asset Health Strategy Committee at AER. We will go to Kim Bowling. Kim is in mechanical operations at CSX. Long history of mechanical ops within that railroad. For the last 6 years, she's been responsible for installation and implementation of their wayside detection systems, from wild to acoustics to machine vision systems. Kim is on Equipment Health Monitoring Committee and very active on Asset Health Strategy as well, and a former chairwoman of the Asset Equipment Health Monitoring Committee. We should also I'd be remiss if I did not mention, Kim's a Vanderbilt mechanical engineering alum, so she's very happy to be home, and she told me she went to one of her old haunts last night, but she's here and ready to go. And last but not least is Dr. Todd Snyder, Director of Advanced Freight Car Engineering with the Union Pacific. Todd directs systems integration and development for UP's extensive wayside detector network. He has degrees in mechanical engineering, metallurgy, and chemical and materials engineering, and he started his career in UP's R&D lab with a focus on failure analysis and derailment prevention. He's led many technology initiatives at UP, resulting in significant safety advancements, and these initiatives resulted also in the implementation of ultrasonic testing for reconditioned wheels, bearing temperature trend analysis, which he patented part of that, and UP's Wayside Device Integration System that analyzes the health of more than 40 million components each day. Todd is currently leading efforts to standardize UP's mobile onboard sensor systems and the development of UP's machine vision platform. In his 20 years with UP, Dr. Snyder's served on many AR committees and technical advisory groups, including the Wheels, Axles, Bearings, and Lubrication Committee, or WABO, former chair of that committee, and the Equipment Health Management Committee, current chair. I might add, if you've ever seen one of the super sites, in particular North Platte's really comprehensive system, it's pretty amazing. Is Ron Hines back in here? Okay. I did want to mention a little aside. Many years ago in the 1970s, I happened to work for a Class 1 railroad that actually gave rise to the term standing derailment. The track was so bad they would have standing freight cars result in gauge spread derailment. Unfortunately, the Staggers Rail Act of 1980, which really rescued this industry, arrived too late to stave off and save that railroad from bankruptcy. So let's let the panel get started, and I'll get out of the way.
Thanks, Pat. You are going to mention.
All right. Good morning, guys. Thank you, Pat. I appreciate all those introductions. Thanks to the audience for being here. My first time at RSI, so appreciate everybody that helps put this on. It's a fabulous event, and you guys obviously do a lot of work there. Like Pat said, my name is Bo Thompson. I'm the Director of Asset Health with the AAR. Previous experience, I was with KCS for 16 years. So I obviously need to update my LinkedIn bio because that is where all that information came from, and there was a lot of hee-hawing in there. So we'll just eliminate that, so next time we get ready to read through it, it'll be a little better. With that being said, the Asset Health Strategic Initiative is the rail industry project. It's going to utilize IT solutions and processes to address our challenges in the world of asset health. Those include, but certainly are not limited to, the 3 bullet points which we got listed here. That's reducing mechanical service interruptions, improving the quality of railcar inspections, and increasing rail yard and repair shop efficiency. The AHSI is led by the Asset Health Strategy Committee, the AHSC. AHSC is comprised of 7 Class 1s, Amtrak, 3 private car owners, and 2 additional associate members. Those member representatives are all listed here, with Jamie Williams, of course, on our panel being the chair. Working directly under the guidance of AHSC is the Equipment Health Monitoring Committee. I heard Pat mention that briefly. The responsibilities there include creating the standards that support the areas of asset health, and we've got 2 of our members sitting up here with Todd Snyder being the chair. Membership obviously is comprised of the 7 Class 1s, Amtrak, 2 additional associate members whose membership is also reflected on our screen here. In addition to those 2 committees, which are directly responsible for most things asset health, we've got multiple technical advisory groups, or TAGs. Those TAGs include the AIR E-Train, that's the Asset Information Repository and Electronic Train. Big responsibility there right now is looking at the electronic air brake slips, among other things. The IQ group, Inspection Quality Group, the DQM, Detector Quality Monitoring, the EFA, Equipment Failure Analysis, Multi-Level Pool Billing, Alert Management Modernization, that's our early warning system, TDTI, which is our Technology-Driven Train Inspection, and Component Tracking. And we're going to cover a little bit of all of these as we move through all the group. So with that being said, that's my piece. Just want to give you a brief introduction of what we're working with here. And I will ask Chip Summey to come up. Thank you.
Right on, Bo.
All right, thank you, Bo. I'm going to talk to you a little bit about some of the work that's already been done in the area of asset health, some of our legacy programs and products. When when AHSI, Asset Health Strategic Initiative, was first envisioned, it was proposed to build upon the work that had already been done in the industry in the area of asset health. And there are a lot of sources and systems of data and information and ways to improve asset health in the industry that already existed. And these systems provide lots of data to form a picture of equipment in the industry to help ascertain the health of the asset itself. And so the things that the rest of the panel are going to talk to you about, and they're going to spend the majority of time on, are the things that are going on right now that will sit on top of those things, provide new value, and then put together and combine some of these sources of health data to create this overall picture of the asset. And I will go through some of the things that we've already done. And so here are some of the areas that exist today where asset health information resides. And some of these applications or systems you may be familiar with, or these initiatives you may be familiar with, and you're thinking, well, those aren't really specifically asset health, but they all contain some sort of aspect where they contain data and they work with the industry in some way to help provide different pieces of asset health data when put together can provide a better picture of the asset. So the UMLR system is one of the older legacy AAR systems. It was formed in 1968, I believe. And you just saw a bunch of acronyms that Bo threw up there. And it used to be an acronym. I was going to ask, does anybody know what the acronym UMLR used to stand for?
Universal, go ahead.
All right, very good, Rick. Thank you very much. So that's excellent. That's right. So as a prize, you can get a all-expense-paid trip to a Union Tank Car facility of your choice, free tour anytime you like. So, or to Cary, yes, you can come to Cary. He does come to Cary and works with us. Thank you. But it is no longer no longer stand for that. UMLR is now just a name, so it's no longer an acronym. But it has a lot of information, not just the characteristic information of the assets themselves, but it contains inspection information. When the last time an air brake inspection occurred on this car, reflectorization inspection information, and also the characteristic information as well helps to identify the condition and the health of particular assets. There's also car grading information, which comes from the accounting side, which can also then provide information. Component tracking is a newer system around 2010, 2012. In that area, the industry was working on tracking individual components to go on rail cars, and looking at also probably doing that with locomotives as well. And as a result of that, that provides a very rich source of our health information about particular components, and not only where, what the components are, but where they are on vehicles. So it helps with, in the event of recalls, we can go and quickly find where defective components might be, put out a recall, and get those components remediated very quickly. It also contains registration and lineage information so that we can track components as they go from car to car. The UMLR, in that way, it works with the UMLR system to be able to track physical assets very well. In UMLR, we have a concept called unique equipment identification, where we can track the actual physical asset even if it goes through re-stencils or it changes ownership. We can track the actual physical asset to be able to then put together a lineage of the health history of that physical asset, not just the asset as it's known by its current stencil mark. The early warning system, as Bo mentioned, is right now being reviewed by industry subject matter experts to see how that can be improved, but I always consider this the BOLO system, or the Be on the Lookout system for cars, and this is run by the Association of American Railroads, and car owners as well as other industry participants can identify cars or groups of cars to be able to put on early warnings or maintenance advisories to remediate those cars. And so looking to see if cars were on multiple maintenance advisories or getting that information also helps to paint that picture of the health of these assets. Down there at the bottom middle, EHMS and Enterus were the industry and are the industry systems for wayside detection information, and that provides information both on detector reads as well as industry alerts and data summaries. If you have been to MARTS in the past, you've probably heard several presentations on data summaries and the value that they provide of showing information over long periods of time for the health of a component, but also contains includes repair information these systems have to know when components were changed out, when inspections were done on components that have been flagged by wayside detection systems. So that's a very rich source of data as well. At the top right is DDCT, or the Damaged and Defective Car Tracking System. It's a good example of why IT folks like myself are not in the marketing business. That's a horrible name. To name something is to call it damaged and defective. I wish I'd have thought of something different, but that's what it is, and it tracks cars that have been damaged or that are defective across the industry. It's a workflow system that can allow car owners and railroads and shops to better communicate about the condition of cars that are fall under Rule 1, Rule 95, Rule 107, and Rule 108, and also tracks defect cars under Rule 102, and that provides another source of information to help with data quality. Now, we get a lot of data in about equipment, whether it's been repaired or inspected, or if it's been involved in some sort of accident, and being able to paint that picture from CRB data, from EHMS data, and then also DDCT data helps, again, to put together individual data points to get a better comprehensive picture. And then last but not least, we have the car repair billing and the locomotive repair billing systems. The car repair billing system is an older system like UMLR is, but it provides a very rich view of detailed repairs that have been done to rail cars. Locomotive repair billing is new around 2010. It was developed by the industry to start tracking the use of locomotive power across railroads and repairs and inspections that were done there. From that system, we also get automated blue card information that we can now provide back to the industry. And so all of these systems and sources of data can be used and built upon by some of the technologies you're going to hear about to be able to provide a better picture of the asset health of cars to be able to hit some of those major targets. And so what are those major targets that Bo mentioned, or things that we're working on now in the industry, trying to work through the health of cars to reduce derailments and increase safety. So some of the things that we're working on there is looking at component information and repair information to see multiple failures or to identify things that are failing multiple times. Trying to increase velocity by reducing line of road failures and making sure that yard and shop efficiency that Bo mentioned is increasing so that we don't have to make multiple stops to fix cars. Reducing mechanical and operational costs by using this information and combining it with other sources of information, and then improving data quality and analytical capabilities in the industry to be able to weave it together and to find factors into some of these costly derailments, into some of these things that are increasing costs. So the industry is working hard to be able to improve our analytical capabilities. The industry is coming out with a data platform for advanced analytics at Rail Inc., and also using TDCI and AAR subject matter experts to be able to work through that to be able to improve the analytical capabilities across the industry as a way to increase our asset health. And so that is some of the things that we have done in the past. So what you're going to hear about now are some of the things.
So I've got 3 slides here. One of the core things to all this tracking and dissemination and analysis of all the information that we try and integrate is to name things correctly. And AEI has been really a wonderful tool that has allowed us to connect the dots between all of these different technologies. And we've really spent a lot of time on it the last 4 or 5 years. It's come up, wow, this is important, and just, 1 or 2 little errors in a train, one error on a train where a tag is said to be an EOT programmed to tell you that it's an end of train device instead of a freight car. The way things work will completely throw that train off. You won't be able to do bearing trending on it, or hopefully not, but you might end up with something where there's an impact wheel that is put on a wrong car. So it's very important. And from a railroad standpoint, it's very important, even on cars that don't go through interchange, to have those things tagged. You have a train coming through, we're trying to figure out what train it is. And so, things get mixed up. So we've spent a lot of time on automated equipment identification, and we aligned the Field Manual Rule 63 last year, and this year, just in July, we rolled out really the first set of alerts, industry-based, where every railroad started by sending in 50 AEI detectors on single main lines across the network, because those are the most reliable, don't have to worry about cross reads from multiple tracks and other things getting in the way. Should be extremely, extremely reliable data, and it's broad enough that it should capture most of the things running out there. And we knew we had our work cut out for us, but we really didn't know till we all got together and put all our data in the same bucket. And hey, there's about 10,000 cars out there that need to be repaired where they've got AEI issues. And it's a constant churn with the renumbering. But at any rate, success for the Field Manual Rule, success that we've got an alert out there for missing tags, or maybe not a missing tag, but a tag that just doesn't work. It's there, but the detector will tell you that it's not working. So that's number one. Towards the end of this year, we'll have mismatch tags, where tags have two different car IDs or locomotive IDs on the same vehicle. And next year, we'll close this out, and I think we'll be done when we take care of the tags that are EOTs, cars or locomotives programmed as each other and not as the right one, and get the axle counts correctly. So anyhow, very happy about that. And I got one little picture down there in the lower left-hand corner of a car that has an issue, and hopefully everybody's familiar with how to get that. Hopefully all these things are getting fixed at the RIP track, but it's been no easy task to fix AEI tags. It really is hard. I think most people would agree, to figure out what train is coming in and what problems are on it, and come up with a tag and reprogram it, and you got to send someone out there in the yard, and they got to get to the right place, and the train's got to be blue flagged to do this work, and there's other work going on. So it's not as simple as, here's the tag, go fix it, done deal. We've really got a lot to do in the process world, and hopefully everyone that touches cars realizes how important that is. Another thing that we've really focused on has been the hot box data sharing and the wheel temperature data sharing. It's the same device in most cases. There's a hot box detector that has a pyrometer looking at a bearing, but in many cases, more and more, it's also got a secondary device that feeds that system that looks at the wheel temperature. And in 2017, we started sharing that information between roads through RailLink on a train level basis, even in cases where we couldn't even identify the cars, because it's such a critical derailment driver that a lot of railroads can just take a train set of axles and figure out what train it is, and then line it up and determine that there's a bearing that's getting hotter. This year, we've focused on taking that to the next level. If you've got the train identified and lined up with AEI, we are sharing the car level for any car that has a problem bearing that jumps above the threshold, which is used in Rule 36 for Y-made, typically 51 or 52, the trending rules or the composite rules with AEI. Something that's at that level will get a message that goes out to RailLink, and then it will be there, a much easier way to integrate, so the roads will be able to pull it in. And I'm not sure, but when or what level that data will be available, but that's sort of a a next step that we'll be approaching. From a wheel temperature standpoint, I mentioned it yesterday, and there's some waivers in the works and waivers going on to use that as a brake inoperative brake assessment tool, both hot wheel and cold wheel. So that is continuing on and gaining steam. And then the acoustic bearing detector data sharing, I want to mention that as well. We've been sharing that data for a long time, and there's been a lot of, there's basically two different types of detectors, TADS and a RailBAM, and right now they're being combined together just to make a more useful one picture of that bearing's health, whether it comes from one detector or the other, and to clean up some of the gaps that we had where a bearing might have been seen by one type of detector once and another type of detector once, and it really wasn't showing up as two bad hits, which of course is something that you'd prioritize higher than one bad hit, or from the closeout standpoint, where you saw something sort of problematic with a bearing, and then another type of detector said it was good, it was good, it was good. Now we're closing the loop and doing that integration. Okay, and my third slide is on just a little bit of a history I put together. I was just going to talk about about some of the things in the red here, but I thought, you know, how are we doing as an industry? Both Ron Batori and Ron Hines were talking about performance-based. That's where we need to get to, and we've been very prescriptive over the years, and so I just sort of listed out in the order of the things that came out in this big data wayside integration type world, what has been going on from my perspective. And it started off with, you know, what to share and how to share it, and how can we use wild or acoustic, or, you know, how do we say that the acoustic detector is good. It was just very functional specifications, how to connect the dots to make use of some data. But detector health has been on the top of everyone's list for 10 years or more. That's a really important thing, and we really haven't cracked the nut. And over the years, we've been getting there, and we've got all the dots connected now so that we're able to share, and we know what the data is, and we've got the definitions of what it means. But the detector health stuff just started to peek in with the wild operative sensors and the variation that was in the original wild spec that said 70% of the sensors must be working, and you can't have too much variation from your track waviness or the track condition. That was the first performance-based one, and we really didn't see another one for a long time until a couple years ago when we put out the S6100, which is all-encompassing wayside standard. Make sure your clocks are correct. Make sure that you're aligning your component with the data that you're taking. That's a really important performance thing. And so we got into it. People may not really adhere to those specs. They're more of targets at this point. But we're getting there, and recently with the wheel profile detector spec, that really had some nuts and bolts, important performance-based sentences in it. Do statistical process control on your data. Make sure that your detector isn't drifting upward and downward. Make sure that it's throwing out back-to-back wheel readings. You shouldn't see those very often. If you're starting to see 1, 2, 10, 20, 50% of those come out of a train passing, you got a problem with your detector. So these things are more and more of the the target that we're trying to hit, just to solidify these detectors as a way that we do our business. The acoustic bearing detector work this year really has been centered on the R&D side, but in order to, and carried by Wobble for the most part, in order to say that this acoustic bearing detector is good, they've done an approach where they do a cross-correlation. This detector found 100 bad bearings today and yesterday, and what did the other detectors say about those cars that this one found? And the conclusion, for the most part, is, hey, they are all acting the same, and this gave us this wonderful tool that I think we're going to, sorry, there's bugs here, that we're going to apply more and more, and the tag, the data quality monitoring tag that's currently focused on taking Wild to the next step is using that particular metric as well as others, just to just to solidify some of these really core things that may not provide a whole lot of value, because the systems honestly are pretty good. We've got a lot of checks and balances in the current systems, mostly that the vendors or the railroads have put in place. But now we're solidifying it. We've got this base that hopefully the FRA and anybody involved in the industry can see that these things are here to stay, and that we've done our homework, and we've got all the I's dotted and the T's crossed at this point. Once we're done with Wild, and I expect we'll be implementing something next year based on the work this year, we're going to go right down the path, hey, what's next? Back to AEI, include hotbox, include acoustic, wheel profile, whatever it is, whatever the new technology that comes our way, we've built that base. All right, so that's all I've got. Kim is up next.
Good morning, everybody. I'm going to give a quick testimony to the AEI that we just talked about. And we think AEIs are pretty reliable, and they are. But on my railroad, we had 5 E53C. So you guys remember your secret FRA cause codes? What's E53C? Oh, come on, bearing guys, you know. Sheasley. Burn-off journals. Okay, I had 5 burn-off journal derailments last year. One of them was from a car that came from a road that shall be not named, but it had tags that were swapped on it. And sure enough, I issued an alarm on it. I changed out axle 1, like my alarm said, but the tags were swapped. And the derailment happened from axle 4 because it was on the wrong side, on the wrong axle. So whenever you guys are doing anything on detector data where EHMS says you have a condemnable condition, check your tags. Okay, that's all Kim's got to say about that. All right, so I'm going to go through 5 more other projects that the committees are working on to make sure that you guys are up to date on that. So the new one that just went to production is the T-Bogey is one name. Optical geometry detector is a CSX name. If you're on the BNSF, then they would call it the truck geometry detector. So, like any good railroad asset, it's got to have multiple names depending on what part of the country that you're in. So this is a detector that measures the lateral and angular movement of an axle. And you can kind of take those numbers, graduate up to a truck performance kind of measurements that are up there. So they've been around for 10 years. You guys don't see the data. Car owners don't see it. Unless you're a detector owner, we're the only guys who see it in the past. So now this data is being consolidated at RailLink. So you will see it up under the EHMS page that's up there. So if you're a car owner, if you want to prioritize cars in your shop, when your tank cars are coming in, you can go in there and look at data. So today it's in a data summary. So who's familiar with the data summaries that are out there? It's a new word that you guys should be learning about if you don't know, if you care about car maintenance, if you want to be able to prioritize your cars that are out there and who needs trucks who doesn't, who needs wheel or bearing changes. The data summary allows car owners and all the other roads to kind of consolidate all the data and to look at it and to prioritize. We try not to make any decisions of who's good and who's bad, but we give you the whole range of detector data, from kind of the medium badge to the screaming bad ones. So data summary is something you should be able to follow that's out there. It's all out there on EHMS that's out there. So that's the T-Bogey that's out there that just went to production early August. So that's out there. CSX and BNSF are the current detector owners that are submitting data for that. All right, pool billing. I know we don't do auto-racks here, but you guys know that auto-racks get inspected a lot of times by outside folks at the loading facilities. I don't know if you've ever seen all the pools that go, the pool data that goes back and forth. If you're not a rack owner, you may not even see some of that. PDFs after PDF after PDF would tell you that I changed, 700 chocks over this time period. No car numbers were assigned to that data at all, so it was no traceability of that at all. So the committee's finally gone through, used the car repair billing model that we all know and love, and applied it to pool billing bills. So now all these folks that do the pre-check inspections and apply new chocks, they actually will have to assign that piece of work, which will have a new job code, and they now assign that to that car. So now it's all traceable. It's all going to be coming in with an exchange process, so you don't have to send paper anymore. Bringing this whole process up to the new world. So I think they're all going to be doing like an iPad kind of an implementation where whoever's doing the inspections out there on these loading facilities will actually go through, zap the car number, hopefully with a tag reader kind of embedded in it, and say, here's all the repairs that I made. I'm not sure why we hadn't done this in the past. It's been outdated for a long, long, long time, and hallelujah that they're doing it the right way. They're also going to electronify, is that a word? No. Electronify? It's a good word.
It's cool.
I think we'll make that a new Kimism. How about that? They're also going to make it electronic of how you exchange the money that goes back and forth between all the roads. So, next. I love this picture. So EOTs is something that some of us deal with. For me, it's kind of just one of those things that are out there. So there's an EOT committee that's been out there. They're working through even sharing data to say which one of these machines are the newer 8-watt models, which kind of antenna that's on there, who's got GIS equipped on it. So all the UMLR features have been modernized and have been updated. In 2019, they'll be able to start sharing GIS data. So today, if I have a BNSF asset that's on my side and I can't find it, I have to call Fort Worth and say, hey, can you ping it for me? Tell me where it is. That's not the most efficient way of doing that. So they're working through a sharing, being able to allow all the roads to share GIS data from the new versions of all these EOTs that are out there. Also, if I have one that's got a dead battery or some other issue with it, today we don't repair, we just send it home. So we're trying to develop, or the EOT committee is trying to develop these test and repair standards that are out there. So in the meantime, even when we're shipping them back and forth, which I know we do between the short lines, we do it between the class 1s. Right now, they get shipped by UPS, and so now they're actually going to start sharing the UPS tracking number, because before, I had to call Fort Worth and say, hey, where's that EOT you said you were sending it to me? It's not here yet, where is it? So at least they're going to start sharing tracking information and just kind of modernizing all the data sharing that it takes to manage these assets that are out there. Today, they're doing settlement by spreadsheet. They're modernizing that as well to allow, again, just like car repair billing, we don't pay car repair bills at the end of the month, but this will allow EOTs and all that settlement, once the data kind of gets cleaned up between, is this EOT on my side or your side, and what was the cutoff date. So now we'll be able to start modernizing that the data as well as the finances that follow along the next month. So all that's getting modernized. So the next gen standards, and this is something I just learned when I was doing my homework for this, is that today I guess the connectivity between the EOT and the header train device that's up there, you can actually have multiples that connect multiple EOTs. Header train devices can connect to the same EOT. So they're working on a new method to do a singular connectivity. So that's the WCC, the Wireless Communications Committee, is working through that to make that a new standard. And they're also working on the short lines, because short lines today get a free ride with the EOTs. It's really the responsibility of the Class 1s that are out there. So in the future, they'll be involved in the process, involved in the interchanges, and work on getting these assets used further. All right. Number 4 of my projects that we're going to summarize is the AER defect forms. You guys have all seen the MD11, MD115, that's the whole set of forms that are out there. Paper-based, you put it in an envelope and you tie it around the bearing or the axle, and maybe it makes it to the shop, maybe it doesn't. So now we're starting to create it on a screen. This is a screenshot from my railroad where it's just an electronic version where it actually sucks in data from the detector and from UMLR, and you'll have a few human filled in fields. So that helps everybody with bad handwriting. You don't get car numbers transposed, you don't get the position on the car transposed. All of that is much, much, much better. So we're collecting it electronically on our road, and now we're actually submitting it electronically as well to RailLink for that central database. So that'll all be going up there. They're kind of moving through all the, I guess there's 5 or 6 forms that are out there. They're all moving forward those in the next year or so. Last of all, what are we going to do with all this cool data, right? Because this is what we want to predict. Does anybody remember his name? Not Johnny Carson, his character's names. Carnac, thank you. I had to look it up. I couldn't remember it.
Great.
We all want to be Carnac and say, hey, I want to be able to predict this broken wheel, burn-off journal, whatever's going to happen bad on my railroad, I want to be able to predict it. So the EFA committee, that Equipment Failure Analysis Committee, is working, taking in data from the MD form. So imagine all the broken components that are coming into that database. The roads are also starting to submit a more extensive version of the derailment file that's equipment-caused derailments. We're submitting that with all the car numbers on it as well as the logic. So we're taking all those pieces parts, bringing them together, and when there are trends that are going on, RailLink is looking at those, looking for trends, and then they actually bring it up to Wobble. So I think in the past it may have taken, I don't know, a couple years to get to all the roads saying, hey, I think I have a problem on this component. And now we're hoping to just shrink that period down so that we see all the data all the time and to be able to find it sooner. You know, maybe take 3 years, bring it down to 1 year, something like that, before we find a problem and the Wobble addresses it. So all that data is coming in, and we're looking forward towards new logic that's out there to go find, and maybe we call this the Carnac Project, you know, so that we have the ability to kind of predict and prevent bad stuff that can happen. All right, well, that's all I have. To Jamie.
Thank you, Kim. All right. So we're going to start over. And the reason I want to start over and start back at just this one particular slide is looking at what all is there that we have going on in the industry and all the people that are involved in making a lot of this stuff happen. So as we look back at how we began Asset Health and the Asset Health task force it was, and then to the strategic initiative, and then the strategy committee. So there were a lot of railroads were doing individual things and not really coming together to make a lot happen together, other than maybe some rules and standards and so forth through the various committees. But what we learned is that together even with the car owners, other committees, that we can make a lot of things happen quicker. Now, we've been into this for about 7, 8 years, and what you're starting to see is the fruit of that. So I just wanted to take a step back and say how much that I appreciate all the work that goes into this from all of the various committees and the people from all parts of this industry, because it's not a railroad, it's not a car owner, it's not an AAR committee or TTCI, it's everybody that's come together to make this happen. So, and I think that's the big testament and the big success story of where we're at today. Because if we think back and we look at car repair billing, and those of you that can remember or have submitted a paper repair card, and then we finally got into the age of putting a repair bill into a computer and then it going over to RailLink, we were still operating under the same rules and same timelines, and we are today. That's what it was when we were submitting paper repair cards. Well, a lot of that stuff is going to change. So if we look at the airline industry, look at the trucking industry, look at all across the board, there's a lot of things that have advanced way farther than what we have with some of the technology, even though that we've got a lot of technology in this industry, and it's spreading, and it's getting contagious. So we're starting to adopt more and more, and as one comes on, we're already planning for the next wave. So, and I'm going to have to comment on Bill. Bill's not one I don't think likes to be pointed out in the middle of a crowd, but I'm going to do it anyway. Bill has done a lot of work through the automated single car test stuff. And I stopped him in the hall and told him how much I appreciated all the effort and dedication that he's put forth through that. So, and that's with he guiding his committees and making it happen. So what do we get? So the industry gets hopefully 2 years when a car's on a repair track that we can bring it in, do a set and release, and it goes. If it's tested with a 4-port, it goes to 4 years. What does that do? The car comes on a repair track and you look out and there's 5 of those that are within those dates. How many cars are you going to get off the rip that day? Maybe 10. Not 2, but 10. So that's huge for this industry, and having people sitting there and guiding these processes and guiding these and championing all of these initiatives is really critical. And the reason I bring that up in this crowd is because we need more of that. We need those people that are going to get out there and champion a lot of these things, make things happen, and we'll start bringing a lot of that's going to allow us to start bringing more of these things to the regulators, showing them what we can do, and continuing to advance the industry. All right, now I'll move forward where I was supposed to be. So when we talk about traceability, it goes back to just like I was talking about the repair car. Here's where we are today. So with traceability, a train leaves a terminal, it leaves on a paper brake slip. That piece of paper is on the engineer's control stand, or it's rolled up, placed in a knuckle, conductor comes out, retrieves that brake slip, puts it on the control stand, there's a paper brake slip. That train is going 1,500 miles, 2,000 miles, 3,000 miles, who knows? But you got to hang on to that paper brake slip. So let's think about this situation. Train leaves origin location, goes 100 miles, it sets off 50 cars, picks up 30, goes another 100 miles, picks up 50 more cars, sets off 40. And then it goes another 100 miles and have a locomotive that goes down and we have to swap power. You've got a brake slip that shows that that train left location A with this many cars, and what do you have? There's not a single car or locomotive in that consist that attaches to that brake slip. But the requirement is that we take that from origin to destination, and that is the governing body of that train. So we have a group in the AAR that's working on that, or through Asset Health, the Air and E-Train group, that is taking it to the next level, which is the electronic brake slip. That way we can have traceability of every car in the train, because even in the FRA's compliance manual, it specifically says that you can alter this slip once you leave origin. But yet, once you get to destination, there's not anything in the consist that actually left origin. So we struggled with how do you do an electronic brake slip from a train level perspective. And again, my friend Bill and another guy from Norfolk Southern, we were sitting in Chicago one day, and they said, why can we not do this at car level? I said, oh, it's not going to, the FRA won't go for it, it's not going to work. So after some persuasion, we went down that path. And we started looking to see how that we can take the car level and what does it make sense to start doing this at a particular car level. So if we take a step back and look at how the FRA looks at the brake inspections and the tests, and if we look at the mileage that we have on trains today, I don't believe FRA would disagree, well, I know they wouldn't disagree that a train can travel farther, but how are they going to have traceability of where it began, ended, picked up cars, set off cars? So if you think about the first scenario I gave you about traveling over the road and picking up and setting off, or just simply going from A to B, there's a lot of variability there in what we're able to do in tracing the origin of a car or a train. So, and because you could see from the 2001 rulemaking that FRA basically said if cars were permitted to be moved in and out of trains at will, the ability to track when and where a Class 1A brake test would be performed would be impossible. I don't disagree with that. So our shortcomings is what had us in a situation, or has us in a situation now, that we're limited on train miles and how we're able to handle equipment between origin and destination. So as we move forward, we're looking to eliminate that. So in the current state, we have to do a new Class 1 brake test whenever we add cars to multiple locations within a train. So if we stop at a location and we want to add a section of cars to the head and to the rear, you just trigger the Class 1 brake test for the entire train. Does it mean that those cars are not interoperable, or you got to check them because there may be something wrong with them? No, not really. It's just making sure that you redo the slip and you go back to adding traceability to the consist. Removing more than one solid block. But take this into consideration. We can, if you can remove a piece of defective equipment from a consist. So if you removed every other car out of a 100-car train, you can still recouple, do a Class 3 brake test, and depart. Does that make sense? But you can't remove more than one complete solid block. Traceability. It all goes back to traceability and how you're able to see what's in that consist where it was tested. So the regulatory modernization piece of this, we're trying to eliminate those restrictions, and we know that safety is not compromised, and we're looking to eliminate the repeat of all the air brake inspections, and but at the same time, we'll still be doing the 215, which is the pre-departure inspection by mechanical and or conductor. So I think overall we've realized that there's no adverse effects to the train, but I think any of us here that either shippers, receivers, carriers, the one thing that we do want to do is get the equipment from A to B quicker and more efficient. Because if you take the example of only adding one solid block of cars to a train at a location, so train leaves origin, goes to an intermediate location. We have 3 blocks of cars and 3 different tracks that are going to go to the same place that this train is headed. But with our current rules, we have to stop, and if we want all 3 of those blocks, we're going to retest the train. Or you're going to have to assemble all of those blocks into one and retest all of that. Or we're going to stop, pick up one block, train's going to leave, another train's going to stop, pick up a block, train's going to leave, and again until we have all the equipment going in the right direction. Is that very efficient? Not really. Is there anything wrong with the safety aspect of a single train stopping and picking up those 3 blocks? No. So what's the problem? Traceability. Knowing exactly where those cars came from, how they were picked up, how they were set off. So as you can tell, a lot of the things that we do in this industry today goes back to how we were able to trace it. And like I said, those shortcomings fall back on us because of how that we've developed some of the systems to be able to monitor and track. Now that we're doing a lot of this stuff through a central clearinghouse, we're able to see that, and we're able to come and have all this information at our fingertips. So what are we going to do? So the current state says that a train can travel 1,000 miles with a QP inspection, qualified person, which would be a conductor or whoever we considered as a qualified person. Or it can go 1,500 miles if it's tested with a Carman or the equivalent, somebody that's considered a qualified mechanical inspector. But yet, we limit that train as well. It can only pick up and set off one time the entire route. So you take an intermodal train that is easily, a lot of our intermodal trains are going to go 1,500, 2,000 miles, right? But they can't run that 1,500 mile stretch, or you're going to leave freight behind, or you're going to pass up freight that they could stop and pick up, which is going to improve the efficiency, simply because we don't have traceability to know where those cars were inspected, and FRA limits us to one set off and one pickup. So there's huge restrictions in this. So where we want to go is increase from the intervals from 1,000 miles for a qualified person to 1,500 miles, 2,500 miles for a qualified mechanical inspector. And that is also eliminating pickups and set-offs of what the requirements or any restrictions on pickups and set-offs. So there would be no limit on it. That is if we have traceability to the car level where the inspection was performed. So what we've done is created the electronic brake slip at the car level. So this thing would be available in real time whenever, if an FRA inspector came up and said, hey, I want to see where your consist has been tested. This could be a print off, it could be radioed and emailed. So there's a lot of ways that it can come back to the inspector. So we'll have that traceability. It's actually going to track mileage going back to zero. So it would show the mileage that's remaining on the car back to zero. As the consist is changed, that information is going to be updated. So it would go into the consist, or when you printed off that consist list, you would see it. So everything's going to be there and be active. They say, well, what if we don't have the ability to do that? Then you're going to operate with the current rules as they are today. So that incentivizes people to look and see, does it help your operation to be able to track electronically and make it robust? If yes, then that's where we want to go. But if not, then there's the option of operating the way you do today or operating through the electronic method. So you're able to do that. All this information is going to be retrievable through RailLink. That's where we house it. So I can send off a request and pull that request back, and it'll come from RailLink, and it'll show me where all of the tests and inspections were done on each car. So essentially, that's going to assign each car with its own brake slip. And if we look at it, this is what you'll see. So as you can tell, looking down the list, it's a pretty big change from what we're normally used to, right? When you run a list of a track or a train consist, do you see anything like that? Know where all the information's at? So we can actually tell that this train came out of Atlanta, and that was the origin of the train and where the cars began. So you can look down the list and then even hit the detail. And under the detail screen, it gives you all the 5 elements of what FRA asked for in 232-205E, which is the notification for the engineer. So everything's there, everything's painted, everything's labeled. You can see the mileage, we've got it -1 because that's the one piece that we're waiting, coming back from RailLink now, they're working on to give the feedback to the road. But you see who did it, where it was done, the car count, the time the brake test took place, the origin date, city, everything's laid out there. Then if we look, so this is the way that we, ENS, would input this information, showing who did the mechanical inspection, who does the air brake inspection. Under type, I can select if it was a locomotive or yard air plant, put in the airflow, leakage, all of this stuff is labeled and laid out. Then, as we're doing the test, if I were to click this car and make a bad order, it would gray out the air brake inspection, so it wouldn't allow the air brake inspection to be labeled against the car. So it's got an audit trail, we can go back and see who did, where it was done. This is actually taking us down a path that we were able to use with what you heard earlier, which is TDTI, the Technology-Driven Train Inspection. And we've been looking at some of the defects that we found there, and go right back and see exactly how many tests that car just went through, where it was done, who did it, and start building up those type of defects or any kind of faults that we see there. So then the final slide, to answer FRA's concern, is the paper bracelet versus what you saw on the detail screen. If we need to recreate that paper bracelet or to be placed back on the locomotive, we can take every one of those elements and fill in blank and recreate that bracelet. So this is not, I don't see this as being an FRA issue of saying, hey, well, you know, we're limited on mileage and so forth. I get the point, and I see it. I see where there was an inability on part of the railroads to be able to supply that information and be able to provide what's needed. Well, you take that one little word that said impossible back in one of the earlier slides where FRA says it would be impossible to track. Well, now it's possible. So now we have the ability to go and look at that. So as we all sit here as part of this industry, the one thing we need to realize is you need to move your freight. I want to move your freight, and you want to receive the goods that you're trying to get. And in order to keep those trains moving, this is the kind of stuff that we have to have. And we have to pass that along to the FRA. They've seen this, and they really like it, which I'm sure they would. I mean, I think, and we like it because we can see a lot of the things that we can improve on from it. So as we go through and we're requesting and looking for people to help with some of these committees and so forth from the car owners and the railroads, think about that. Because there's a lot of things that are happening in this industry and a lot of technology that's continuing to roll forward. So, and we would like to have all the help we can get. All right? That's all I have. Thank you.
Questions, comments?
The air slips, you wouldn't need to put the train ID in there anymore because it's all car level?
That's correct. Well, and you're not required by regulatory to put a train symbol in there.
Okay.
So the regulation doesn't require a train symbol, so it's drilled to they're trying to drill it to the actual consist and not train symbol. So now that we're taking it even to the car level, then it really doesn't justify the use for symbol even further.
Okay, makes sense.
Anything else out there, recognizing that we stand between you and lunch? It's really a pleasure to put this panel together or session often. It might take a little cajoling now and then to get them to commit to presenting, but once you do that, you can see how they take it and run with it. It was great. And Kim, sorry I didn't answer you on the bearing cause code, but as an OEM, I didn't want to do that on your E53C. And finally, it's very gratifying to see the Ticket to Ride concept at the individual asset level finally coming to fruition. Many of you may not know the initial TDTI goes back 15 years, and we talked about it. And the TDTI was 6 of the 7 Class 1s, AAR, and TTCI. What was the missing piece? Bingo, there were 2 pieces. The roads didn't have that kind of granularity necessarily back home, and secondly, Rail Inc. and the centralized warehouse was missing. So here we come. TDTI really was initiated in parallel to ATSI because it was recognized The industry didn't get much at all in the 2001 power brake revisions outside of a very onerous extended haul provision and some relief on cycles trains and not much else, maybe a little bit on movement of defective equipment. So good to see all this work come together with the focus and the right players at the table. Finally, it's my pleasure, I'm not going to present individually, but we'll give the panel their paycheck, their plaques, and thanks a lot, and we'd like to have a round of applause for them if there are no other questions.